we're talking about some research I've done over the last few years, and specifically this year, two major trials I did. And talking about Nano-Silica from Aquariton. Now, it's fairly new in turfgrass. Now, I have to say, I hadn't heard of it up to a few years ago, and I've been around quite a while. And it's been used in agriculture and horticulture, Nano-Silica, over the last few years now. And they're getting some really good results and some positive feedback on it. So regarding turfgrass, it's fairly new. And I think Aquariton are the only ones that I know of are providing it anyway. So today I'm going to show some of the findings from the research trials I've done over the last couple of years. So what exactly is Nano-Silica first, before we get into the trials, because, you know, it is a new subject. So basically, it's a form of silica. Now, everyone's familiar with silicon dioxide, well, silica anyway. But Nano-Silica are particles of these which are ranged from 1 to 100 nanometers. And the Aquariton products have it's around 20 to 30 nanometers in size. So I mean, what on earth is a nanometer? Well, a nanometer is 1/1000th the size of a meter. So I'll just put that into perspective. I'm sure everyone is familiar with a millimeter. You know, we're cutting our greens at 3 mil or 4 mil. So 1 millimeter, quite small. 1,000 times smaller than a millimeter is a micrometer. And 1,000 times smaller than a micrometer is a nanometer. So a very, very small particle we're talking about here. And you could think of it, instead of a powder, Nano-Silica would be a very, very fine, almost a dust-like particle. Comparing a grain of sand to a very fine dust. It's a very small particle size. And because of this very small size, it affects the whole properties of the silica. So because it's so small, we'll just stick these up, and it has a very, very high surface area to volume, which means that there's a lot of surface areas there which can react with other compounds, with other elements and other molecules. So big surface area to volume, which is beneficial. Another thing is that silica itself is quite inert. It doesn't respond to much reactions really, which is valuable for us because it means it can be used to piggyback other elements, other compounds and nutrients into plants without causing any sort of side effects. So it's a very good carrier, basically, for various nutrients. Now, it can be formed. Nano-Silica particles are formed using various processes, which I don't know much about, I have to say. But there's a list of things that are used to process the Nano-Silica. But it's during this process where, when they're being formed, the nanoparticles can be modified and they can be used then to interact with nutrients and elements. So you can attach various elements to these nanoparticles, and basically you're using them to piggyback or to distribute these and to deliver these other elements in a very efficient manner, in fact. So basically, Nano-Silica particles are acting as a nutrient carriers to deliver the essential nutrients for plant growth and other functions as well. That's it in a nutshell. So it's just a good delivery system, really. Now, silica itself has a lot of benefits. A very interesting element, I have to say. Back before I even started doing a PhD, I looked at phosphate and plant disease resistance from phosphate, but I was very strongly thinking about looking at silica instead, because it was such an interesting subject. But silica itself, there's my little laser, you're going to get enhanced nutrient uptake from Nano-Silica, as I just said. But silica itself is very, very valuable numerous areas for enhancing stress resilience, for example. So you're going to increase resistance to a whole range, apart from disease and pests. Silica will enhance resistance to things like environmental abiotic stresses, such as drought and heat, salinity, and also has a very interesting effect on moisture availability. Regarding soil, silica will enhance the structure and also affect the root development. So you're getting better moisture uptake from the root zones. And other studies have shown that it will enhance the growth, a better plant growth, stronger development, increased biomass. So, you might think, well, this sounds like great stuff altogether. I mean, but don't take my word for it, because there's a lot of research in plant systems showing that. Just on the subject of nano-silica nutrient delivery compared to conventional fertilizers. So if you look at, say, nitrogen, which is the most important input we're going to give out to our turf grasses, really. But the experiments have shown that you will increase the nitrogen uptake in regard when you're delivering it with nano-silica. And as we all know, applying standard normal fertilizers, you will lose a lot of it from things like volatilization or from leaching from the soil. So you're going to reduce that. So economically and for the environment is actually a better result also. And again, just regarding the nano-silica size that I was just talking about, so the aquarium one actually goes between 1 to 30 nanometers. So very, very small particles and very rapid uptake and assimilation into plants. Again, just to go over the benefits of silica: increased root development, increased surface area, better uptake of major nutrients and minor micronutrients as well. You will get better root systems, better access, therefore, to water. That's a big thing these days, of course. But also it affects the plant morphology itself, along with turf grasses. It actually can help to reduce transpiration. So again, you're reducing water usage, and more efficient water uses actually. And of course, silica is very effective at reducing stress from abiotic and biotic factors. So you're getting increased cell wall strength, so strengthen the cell walls so that things like pathogens slows the infection process, allowing the plant to respond. And so very good all around, various factors that silica is going to improve your plant growth and development and that. As I said, there's a lot of research published regarding the use of silica and plant systems. I mean, you have things like all of these here, and also a lot of published data regarding silica, and in fact directly with turf grasses. There's one: silicon improves heat and drought stress tolerance associated with antioxidant enzyme oh my God. Do you know what? There's actually a competition when you're publishing a paper to come up with the longest and most complex title, I think. But anyway, a lot of research with silica and a lot of research with turfgrass also. So as we can see, it's a promising tool that we might be able to use. Fairly new, as I said, with turfgrass.